Welcome to qnawire.
In this problem, we need to solve for the velocity of the rod CD after rod AB strikes it. So, rod AB swings at an angular momentum omega 2 and linear velocity v2, then hits rod CD lying flat on the surface. So, you can see that in my sketch here on the left part of the screen. So, we'll apply the principle of conservation of energy for the motion of rod AB from position 1 and position 2 as shown in the sketch here at the right part of the screen. Okay, so for position 1, we have no potential energy and kinetic energy because the rod is just suspended in the air horizontally. And then for position 2, as you can see in the sketch, our potential energy is equal to negative mg L over 2 because our reference point is point B and the center of the rod is at a distance of L over 2 away from point B, so below point B. So that's why we have a negative sign there. And then K2 is equal to 1/2 mv2 squared plus, so 1/2 I omega 2 squared because the rod is now swinging. Now, substituting the expression for V2 which is in terms of R and omega, so that would be V2 equals L over 2 omega 2. And then the moment of inertia, since this is a rod, is equal to 1 over 12 m L squared. K2 becomes, so K2 is now so 1/2 m L over 2 omega sub 2 squared plus 1/2 times 1 over 12 m L squared omega 2 squared. So simplifying this, we'll get 1 over 6 m L squared omega 2 squared. There. So hence our conservation of energy equation would be, so that's U1 plus K1 equals, so U2 plus K2. Then we don't have anything on the left hand side, so that's 0 equals, so negative mg L over 2 plus 1/6 of ml squared omega 2 squared. So simplifying the equation, so let's move negative mgl over 2 to the other side, so mg L over 2 equals, so 1/6 m L squared omega 2 squared. So from this, we can get omega. So omega sub 2 is equal to the square root of 3g over L. And since we now have an expression for omega 2, we can also have our expression for v sub 2. Hence, so v sub 2 is equal to L over 2 times the square root of 3g over L. So, to have more equations, so we can also analyze the impact between point A and point C. So, the coefficient of restitution is equal to, so E equals, so VC minus VA3 over VA2. So, as you can see in the sketch, so VA2 here is the velocity of point A. Sorry, this is VA1 in my diagram. So, VA2 is the velocity of point A before the impact with rod CD. And then, VA3 here is VA2 in my sketch. So, this is the velocity after the impact with rod CD. So, from here, we can find an equation for VC. So, VC is equal to E times VA2 plus VA3. There. So, expressing VA1, VA2, and VA3 in terms of R and omega, so we'll have VA2. So, VA2 would be equal to L omega 2, and of course VA3 would be equal to L omega 3 because point A is at a distance of L away from point B, which is the point of rotation. So hence VC will be equal to E L omega 2 plus L omega 3, and that would be equal to E square root of 3g L plus L omega 3. We can also apply the principle of impulse and momentum and solve for the moments about point B, taking the counterclockwise direction as positive. So, we'll have the equation, so M V2 L over 2 plus I omega 2 plus 0 equals, so M V3 L over 2 plus I omega 3 plus MVC L. So, substituting the values for V2, for omega 2, for V3, for VC, and for I that we all have established earlier. So, our equation would be, so this is quite long, so M times L over 2 times square root of 3g over L times L over 2 plus 1 over 12 ml squared times square root of 3g over L, and then equals, so m L over 2 omega 3 times L over 2 plus 1 over 12 ml squared omega 3 plus m, then L, and then the equation for VC, which is, so E square root of 3GL plus L omega 3. So, simplifying the equation, combining some similar terms. So, we'll have, so M, this will be ML squared over 4 times 3g over L plus ml squared over 12 times, again, 3g over L equals ml squared over 4 omega 3 plus ml squared over 12 omega 3 plus ml e squared of 3gl plus ml squared omega 3. So, combining the terms on the left-hand side of the equation, then transposing ml e squared of 3gl to the left-hand side. So, our equation would become ml squared over 3 squared of 3gl minus mle squared of 3g over l, and then mle squared of 3gl equals, so for the right hand side, so we'll combine all terms with omega 3, so that would be 4 ml squared over 3 omega 3. So we could factor out ml squared for both sides and it will be cancelled. So we'll be left with, so omega 3 would be equal to, so 1/3 3g over L minus E 3g over L times the reciprocal of what's on the right hand side, so that would be 3 over 4, so equals omega 3. So simplifying this, we'll get, so omega 3 equals, so 1 over 4 minus 3 over 4e times 3g, square root of 3g over L. So we factored out square root of 3g over L. There. So that's our expression for omega 3. So now that we have the value or the expression for omega 3, we can now solve for VC. So VC is equal to, so E times square root of 3gl plus omega 3. So substituting our expression for omega 3, this becomes E square root of 3gl plus, so L times 1 over 4 minus 3 over 4e square root of 3g over L. So simplifying this, so VC is equal to E square root of 3gl plus 1/3 square root of 3gl minus 3 over 4e, 3 over 4 times E times square root of 3gl. There, so we can combine the terms with E square root of 3gl. So we'll be left with, so VC equals 1 over 4, 1 plus E times square root of 3gl. Now, so substituting the values with E equals 0.4 as given in the problem, so VC would be, so 1 over 4 times 1 plus 0.4 square root of 3gl. So since we don't have the value of L, so this would be equal to 0.606 square root of gl.